welcome. Today I'm going to be talking about OpenTelemetry, specifically on how I got OpenTelemetry working in a polyglot environment. Before we begin, my name is Michael Sickles, and I'm a solutions architect at honeycomb.io. And so I've been working with our customers recently, setting up their instrumentation for their environments using OpenTelemetry to get application insights, and that's what it's really for. OpenTelemetry gives you tools, APIs, and SDKs to ask questions about your system. So seeing things like traces, metrics, and logs. And why it's important and useful is that it's a standard so that you can spend the work to instrument and get these application insights once, but not have to redo it later. Typically, the old style is a lot of the vendors out there have their own proprietary format on how to add instrumentation and get insights. And it's frustrating when you want to either try multiple tools or switch to a new tool, because it takes work that you have to lift and shift and rewrite code in order to try things out. With OpenTelemetry, you do that once. And then as you move along, you can keep adding the OpenTelemetry insights as you develop new code. You can then point it to one or multiple vendors, to be honest. And from there, you can see which tool is going to be best for your situation and where you're going to get the most value. You're no longer locked in just because of all that work you put in up front. And so I wanted to find a good demo and good environment to help our customers see how to use OpenTelemetry. There's a lot of examples on individual, like here's a Node app. How do you set it up for a Node app? Here's a Java app. How do you set it up for a Java app? But there's not a lot of good tutorials or examples on something that's more complex, something that is distributed tracing and talking across multiple different kinds of code systems. And so I found the CNCF Google Microservices demo. This is a microservice on Kubernetes, and it's polyglot. So it's got Node, Java, Go, .NET, and Python, which also uses OpenCensus. So OpenCensus was the way it got its telemetry insights. And OpenCensus is a standard before OpenTelemetry. And there was another standard called OpenTracing. And OpenCensus and OpenTracing decided to come together. Let's unify the standard and have one. And that's where OpenTelemetry came about. They merged together. So I could take that OpenCensus instrumentation and know I can switch it over to the OpenTelemetry style. There might be some semantic differences, but I could say, look here, it's using OpenCensus to get insight here. Let's get insight in OpenTelemetry as well. The application itself is on the right, and it's an e-commerce website. It allows you to find items to add to your cart, check out. You can convert different currencies, you can get ads, and these are the different services that make up your application. And what's going to happen is we're going to start at our front end, which is written in Go, and we're going to take some kind of action. Maybe it's add to cart, or check out, or see add. These are the traces, and I'll get more into that later, that we're going to follow through as it makes a call to a backend service, which might make calls to other backend services. And these are on different servers, and that's, the different coding languages. We want to be able to watch one call, one action, one transaction, and see all the different pieces that action talks to and connects to. And what that allows us to do then is we can see where slowness might be in the system, or where there's errors in my system. I can target and get to root cause faster with a tool like OpenTelemetry and some vendor out there. When I was considering, how do I instrument? What do I want to do? I right away thought I'm going to reuse that OpenCensus code. Like I mentioned before, it's already in place. I can just convert it to OpenTelemetry semantics and OpenTelemetry libraries. It will give us good insights. Just gonna go follow the front end to the back end. So I'll start with that front end first, move my way to the other services it talks to. And then I'm gonna use automatic instrumentation when possible. When you're going through and adding telemetry to your system, all the different code languages have various ways to have automatic insights. And that can vary from automatically hooking, say, into the JVM for Java, to pulling in specific wrappers that are going to wrap the libraries themselves and say like Node.js to automatically do tracing for us and automatically starting and stopping units of work for those libraries. So if we can do less work for us, that's great, right? That's another benefit of OpenTelemetry is we have all these different organizations working on it, where that if there is a library being used at one organization and they can then add the instrumentation pieces that might make its way upstream into OpenTelemetry, then any other organizations that might use those libraries can get insights. Finally, though, that I'm going to want to add manual instrumentation as well. So you can get a lot from automatic instrumentation, but it can only take you so far. You know your system better than anyone else, and no automatic instrumentation is going to get to where you need to really understand the state of your system, because you got this auto instrumentation, which is good, but take it to the next level. You can add things like user details or server details or product details that are really going to be those nuanced differences on why your system might be performing or breaking in different ways. And by adding in those details, you can ask more questions about your system. And that's what we ultimately want to do, is we want to understand how it's performing and maybe for whom does it suck in my system. Before I go on, let's little bookkeeping here, terminology. So a span is a unit of work. It's an action in code. It's maybe a function, a method, and it took some amount of time. It took 3 milliseconds, 20 milliseconds. Like it's something we measured. And then we have a span attribute. So we're going to add contextual details. That's that user ID, session ID. We want to add the variables in our code to the span so I could understand what was going on in my system at that specific point in time. And then I can add span events. That is essentially a log attached to a span, more or less. It's something that doesn't necessarily have a duration, but is something that is interesting. So for example, an exception. If there is an exception, we want to take that information and attach it to this specific point in time, that span, that unit of work, it's where it happened. But an exception doesn't take a certain amount of time. It's just something that happened at a point in time. A trace then is a collection of spans for a certain action that add to cart, that check out. That is something that your users are doing, and it's going to touch different spans as it goes through different pieces of your code and connect them together using a unique ID. So that OpenTelemetry is automatically generating that ID and able to connect it across your code, that your vendor tool choice is going to be able then to render it some way in the UI in some kind of view to make sense of that. If you ever see me talk about OTLP in this presentation, OTLP is just the specific protocol and format for OpenTelemetry itself. And then exporters. Exporter is where we are sending our data. So you can export to the window, the console window, or we can export to a vendor. We can export to somewhere those application insights. So I started with the front end, and we can see that I ripped out the Open Census libraries. And this code, by the way, this GitHub repo of where I made these changes will be at the end of the presentation as a follow-up for if you want to go in and see the specific things that I changed from Open Census to OpenTelemetry. You can see all the changes I did using the Git history and compare. I'm not going to throw in every single little code change I did just because it'd be something it took me a couple hours to do, and thus I can't keep it in one presentation. But yeah, I loaded the OpenTelemetry SDKs, so you can see us changing. You can see some of the libraries have similar naming. So for example, there's an Open Census Trace. Well, there's also an OpenTelemetry Trace. So that it's that idea of traces and spans are similar across the two. And then I had this idea of auto instrumentation and we're going to have wrappers around the various libraries. So in this case, I have a Gorilla Mux router, and I want to automatically get insights on my different HTTP requests. So there is a library out there that exists that automatically does that for me. I import it in and then just wrap my router. When we go through in OpenTelemetry, this is going to be pretty common across all the different coding languages, but we're going to go through and we're going to create some kind of exporter. We need to send our data to a location. I've removed some vendor-specific information in here, but the gist is you're going to send it to some API endpoint. If that API endpoint is secure, you're going to have to be careful with that, and that you're going to want to have some SSL credentials. So this is a nuance I found going through. Go doesn't automatically infer if it's, HTTP or HTTPS. You have to add in these blank credentials to say, hey, this is going to a secure endpoint. But if yours going to an unsecure endpoint, you wouldn't need that specific piece. And we're exporting in that OTLP format over gRPC. The next thing we're going to do is we are going to create this tracer. So what this tracer does is it's going to automatically propagate the trace context, the tracing information, connect and create that unique ID. And then we're having this span processor that's just processing our spans. We have a batch span processor. Rather than hitting the endpoint for every single event, it's going to batch them together so that you can save some network bandwidth. And we just have to add a little bit more contextual information. You added a service name for my front end here. Beyond that, there's a couple of other pieces in code that I wanted to add. You can see at the top that r.use middleware. And when you look at the code, that is me taking that OpenTelemetry middleware and wrapping my Gorilla Mux router and getting that auto instrumentation piece. That's what I wanted, right? Beyond that, the microservices demo uses gRPC to communicate to all the different backends. So there is actually an OpenTelemetry gRPC wrapper as well. And so I was able to utilize that to automatically add trace context and span durations for my gRPC calls. So great, rest work for me. But I do need some manual instrumentation. Ultimately, if I'm going to ask questions about my system, I want to understand what is going on in my code. So for example, maybe that session ID, I get a support email and I can look at that session ID to be able to see what happened for that user. So not only am I understanding like high level details of how my system is performing and how my calls are doing, I now am empowered with extra details for the variables in code. I have things like an email, in this case, a zip code, state, country, and session, but I can add absolutely anything that I think will be useful for me later when I want to ask questions about that data. So with that, I was able to deploy it. The Google Microservices demo uses Scaffold to automatically deploy in this Kubernetes environment. This is in our AWS cluster. And honestly, I just took that front end instrumentation and I copied it. There is 3 other Go services, and how you do it in one coding language, you reuse that. Copy and paste, just change the service name. I use the same like gRPC wrappers because they also use gRPC to communicate. It was something that was pretty easy once I got the first front end working. So from there, I needed to do my next service. And I was looking downstream, like I said, front end to back end. Well, this front end is touching this add service. Java is really nice. So for Java, it has an agent. And this is different from the other libraries and other coding technologies. Those use SDKs. Java has an agent that can hook into the JVM itself. And as it hooks into the JVM, you just set a couple of environment variables. You can see down here on the bottom, and it's coming to the rescue. It's just going to hook into and has a long list of automatic instrumentations, tons of different libraries like Spring and databases and HTTP calls, Kafka. It's going to wrap those automatically for you from like the JVM context. And you're going to get a lot of good insights in Java. Java is GA now. When I originally did this and you look at the code, I still need to update it. It was like version like 16 or 17, but now that it's GA, I do need to eventually update to the newest Java agent. So starting with this Java agent, that's great. But there was existing open census manual instrumentation. And one of the things I wanted to do, as I said, is reuse it, right? And so you can see how the terminology is very similar from the open census to OpenTelemetry. And this is common across a lot of the other languages as well. But here you can see I wanted to add attributes. And in OpenCensus, it was put attribute. Now I just switch it over to set attribute. Easy change. Add annotation became add event. So now I have a span event, and I have that logging information with context about my Java application, and that's awesome. Java also has a really neat thing in that you can take the manual instrumentation and SDKs and hook into the automatic instrumentation. So it has this at with span annotation that will automatically wrap your function call here and do the tracing and the timing for that span, that get add span, which is great. And then I can get this span.current to get the specific span in the auto instrumentation, that point in time that I am at, and add in different attributes. So that's that set attribute, the add event, etc. This allows me not to have to sit there and manually start and stop my spans. That's something I was trying to avoid if at all possible. Just that's a little bit more work. With this, I got going pretty quickly, and I started seeing add service information in my code or in my vendor tool. So I'm gonna continue down that path of I want to trace across multiple parts of my system. Moving down from the checkout service, I see that it touches 2 node services. So I decided, let's just go there next. So inside my payment service, this is one of them. Node is a little bit different, and this is a common theme. There's going to be a little bit nuances. The Node code uses this tracing.js file, and that's going to be start up with a Node command. So you'll see in the Docker image for this in the source code, I just added, hey, start up with this tracing.js, and I'm going to go through and do similar things. I'm going to have an auto instrumentation piece. Node is nice in that you can wrap or rewrite the JavaScript code. So in this case, I have plugins, and I'm loading in a gRPC plugin. Once again, gRPC calls is what it's making, and an HTTP plugin. But there's multiple plugins out there. There's an Express plugin. If you go on NPM, you can find them, and it's also on the GitHub, and it might not be yet in the docs, but I'm sure it'll be there soon. You just npm install these plugins. In reality, I shouldn't have had to actually manually put this plugin code, this plugins and enabled and location. It should have automatically, according to the docs, done it for me. It wasn't working, so I manually said, hey, these are my plugin names. This is where they're located. Please enable them. From there, we're setting up a collector again. Java didn't have it where you needed to do this create SSL, but Node does. I have to create SSL credentials if I'm sending to an secure endpoint. And in this case, for this specific implementation, I am. And with that, I'm also exporting in my OTLP format and gRPC. So I have to be mindful of using the right Node libraries. gRPC is usable in the backend, so I can use that in my OTLP format so I can send it directly to this vendor. With that, creating my tracer, I'm going to, in this case, just kick it off, register it, and add the instrumentation, the auto pieces, and go see what is in my UI eventually. But there is some things to understand. There's more nuance. It's not always great. For example, when I wrote this, Node, and it still might not be GA. I'm pretty sure it's still not GA, but it's working towards it. Node not being GA means that there are going to be sometimes changes to the spec, the APIs, and how you do things. And this is a case of when I originally did this compared to now, there is a little bit different on how you might do things. I will eventually update the repository to use the new method and add in the versions or update to the newest version of the Node.js OpenTelemetry. But essentially, it's similar. Instead of a plugin, it's an instrumentation. It's still loading that auto piece and wrapping around it. All right, so now I have my 2 node services. Once again, I'm just copying and pasting my tracing.js, and I'm going to move on to the next piece. And that next piece, I decided to go downstream to this cart service coming from that checkout service. It's .NET Core. And with .NET Core and .NET, there's once again, more nuances. So these are things that I had to kind of work out, going through the documentation, going through the GitHub repos. .NET uses the built-in Microsoft profiling libraries, and so there's a little bit of differences in namings. Like if you were to use the manual instrumentation, you'll see they have a little bit different terminology on adding attributes, putting attributes, etc. But at a high level, getting that automatic instrumentation was very similar, pretty straightforward, in that I have a startup file where I am configuring my services, and I'm going to initialize my telemetry. So I add my tracer, my OpenTelemetry tracer, to the services itself. From there, I'm having my instrumentations. So instrumentations is my wrappers. These are my automatic instrumentations. Automatically take that trace ID, automatically take the durations on how long pieces took, and less work for me. With that, I then also want to add an exporter. Once again, OTLP format, and I'm going to a specific endpoint. I remove this vendor-specific code in here because you might have to add things like API keys and the vendor URL where you want to send the data, but you should be able to take this and apply it to different vendors, at least from a reference standpoint. And then, of course, finally, we see that same issue. We need to make sure empty SSL if you are sending to a secure endpoint. And in this case, it's gRPC secure endpoint. And I left the automatic for the .NET. I didn't add in the manual instrumentation yet. That is still on my to-do list. So I decided to move downstream once again. All that's left is 2 Python services. I'm getting close to the end to be able to see this grand trace of my system, to see communication between services. So I have this email service in Python, and I personally have not used a lot of Python in a production environment. I've used Python from like scripting, but not really in terms of like a web application. So I had to do a little bit more reading up and figuring out how like a requirements.in worked. And so using that requirements.in, I was able to once again remove the open census code and libraries and references, and instead add the OpenTelemetry stuff. The documentation was a little bit lacking on the Python side. I think it's just the nature of things are still growing and are still in flux for some of the languages, but it will get there eventually. We're following the same thing we did before. We have an exporter, and with our exporter, we are doing OTLP format to our endpoint like before with empty SSL credentials. Great. We have a trace provider, a tracer, whatever have you want to call it in the different languages. And in this case, we give it our service name, and we're adding our span processor. We're just going to simply export to this location. And then I wanted to add some manual instrumentation as well. There is this server interceptor. This is a OTel specific wrapper for my gRPC server, and it allows it to get that trace ID from the upstream calls and automatically add it to the Python calls. And I like that automatic instrumentation. As I've mentioned before, I kind of want to get going quick and see what I get out of it, and then add my manual instrumentation later. So we got that. What does it all look like? Did we actually do it? And the short answer is yes. The long answer is it took me a couple tries. There was a lot of learnings in that where I didn't get tracing propagating right. I had to add for example, that in that Go piece, I had to add that automatic gRPC instrumentation, because without it, it wasn't propagating the trace IDs. And that's really the problem, and why I wanted to do this is there's all those good examples individually, but we really need more examples of a complex environment where microservices architecture, talking to different types of code environments, and tracing through it. And so here's a grand trace. This is in Honeycomb because I work for Honeycomb, but it might look similar in the tool that you choose. And we can see that we are tracing across services. So it's taking that trace ID from my front end, sending it to my checkout backend, It's telling me how long I spent. That's great. This is the power of a trace and a span and a trace waterfall view, is I can see where most of the time is being spent. I can follow through and I see from that Java piece or the Go pieces or whatever have you, they all have these ideas of span events. And I can see those span events in this case as those dots. Those are maybe those exceptions or log messages that are important. And those span attributes. So now in my system, I can ask questions. I can see someone at example.com. What was their experience when they did a checkout? And that's ultimately the thing we want to solve for, right? We want to understand where the bottlenecks are. We want to get to root cause, because if your system is down, your users are not happy. And we want our users to be happy to continue using our products. A lot of lessons learned. Honestly, the biggest problem I had when going through all of this is the documentation can be lacking for some of the languages. I did have to sift through the GitHub code itself. That is continually changing. Already since I did this a few months ago, there's better documentation. More of the languages are GA. OpenTelemetry is moving very fast and it is becoming more and robust like daily. And this is why it's important to have this nice and open format, is you have the mind share of everyone out there who is interested in it to be able to work on it. And that's great. But with that, we saw that some of the languages are pre-GA. That is a risk you might have to take, but that is, once again, also continually changing. More and more languages are becoming GA, and I expect that, at least for tracing, to really be pretty robust on all the different languages we've seen today to be GA, right? Metrics and logs, those are in the pipeline for OpenTelemetry, but eventually we'll get there too. There's the different nuances I saw. So I was having troubles with that SSL piece, and that is something I had to just dig into the code and figure out why I needed to do it for like some of the languages, but not for Java. And I figured out that it's just one of the nuances. We definitely also need more examples. Like I kind of mentioned that the individual examples are good. You can go into the GitHub. They all have examples on how to use OpenTelemetry. Tons of vendors have examples on how to use OpenTelemetry for the individual languages. We need more examples on complex real environments, because that's where you're going to run into the more nuances, the more edge cases on how to set up something, how to get tracing across the different languages, for example, right? Hopefully, now with this Google Microservices demo, that's going to help some more people out there, and I'm going to keep updating it. Auto instruments, your mileage may vary, so that is something always to keep in mind. Auto instrumentation is good, definitely, to get up and going. It's not going to be the end be all. It's not going to solve all your problems for you. I don't think it will. So be prepared to go in to do some manual instrumentation. And yeah, I need to add back in some of the health checks. I had to remove them because for some reason when I added my OpenTelemetry, the Kubernetes pods would crash because they weren't starting fast enough. But when I removed that health check to see if the pod was ready, it started up fine. That's just something I need to do to get this demo back to a good standing on how the original OpenCensus stuff was. So my next steps, add more information. Just recently, I wanted to figure out how to use baggage. And so I was able to dig through the docs, dig through code, figure out how do I add baggage. And I got baggage working. So baggage is taking something like that session ID you saw earlier, and how can I propagate that as well to all the downstream calls? Not just a trace ID, so that I can set something like that session ID on every single one of my spans. And I was able to add that into the code. You'll see that, at least for the front end and a couple of the pieces it touches. I definitely need to add more manual instrumentation. That's another piece that might be lacking in some of the documentation, is how to get specific situations set up. So I want to make sure I have all those situations for any of my customers and anyone out there who's interested in setting up specific attributes and such for the different coding languages. Eventually, we also want to use this as a demo environment. And with that, we want to be able to add some arbitrary slowness. Your tracing tool should be able to identify bottlenecks. And we want to be able to showcase that even in a complicated environment, we can add slowness and quickly identify it. And you should make sure your tool that you're using can do that as well. Obviously, I just mentioned health checks need to go back in. And then finally, I need to update to the latest versions. Feel free to make some PRs to the code. It's fast. The OpenTelemetry stuff in just a few months has just updated multiple versions already, as everyone is working towards that GA for all the different languages. So eventually they're going to get, all of them will get to stable and it'll be perfect and great. Until then, just going to have to keep monitoring and get it to update. Thank you. I really appreciate you taking the time to watch my presentation. Here's some of the resources at the bottom there. You can see the microservices fork that I created on our GitHub repository page. Also, you can look at the OpenTelemetry docs and GitHub. That's where you're going to find a lot of your information to really understand how to use it. And then there is also a Slack channel. The CNCF Slack does have OpenTelemetry channels for you to ask questions there as well. Thank you.